In this video, I want to talk about some of the different types of joints that we see in the body, or maybe more accurately, some of the different types of models that we have for joints in the body. And what I mean by that is, as I mentioned in my last video, quite often we want to reduce the complexity of the body down to something we can understand. So there's a couple different types of ways we can think about joints in the body moving. I'm going to list them here and then we'll go through them. First off, and maybe simplest of all, is something we call a hinge joint, sometimes also referred to as a pin joint. That is like a hinge in a door. The pin joint term comes from, say, maybe imagine you have like one piece of paper like this and another piece of paper you kind of overlap with it a little bit, and you take a thumbtack and you pin them together. Now, this could rotate like that, right? It can only move in one direction. It can rotate this way or it can rotate this way. So it's a super simple kind of joint, and it's a good example. This might be the knee joint or the elbow joint. Knee, elbow. So we can think of it as just being like a hinge that can flex or extend. The next type of joint that I want to talk about is a ball and socket joint. Classic example here would be the hip joint. And how to conceptualize that is like maybe you have a little stick coming off and a ball, and then that ball sits inside a socket like this. So you have kind of like a hollow sphere and then a ball that goes inside it. And because of that, it can move around in different directions, and importantly, it can rotate. Next up, there's something called a pivot joint. And it's almost like a pin joint turned on its head. The best example here is like vertebrae, or maybe your head. See, the problem with the head, like your skull on the top of your neck, is that it's really more of like a ball and socket, isn't it? Because it can move around in all different directions, and it can rotate. So vertebrae, probably the best example of this. So what that might look like if you drew a really simplified sketch of it is you got something down here. It's got a little cylinder like this, and that goes into some object up here that's got a little hole for it, and it can only spin like that. So just like the hinge joint, it can rotate only in one direction, but usually usually this kind of happens in the transverse plane maybe, and we're just pivoting around on that joint. There's two more rare types of joints that we see at a couple different places in the body. One of them is called an ellipsoid joint. And the way to think about that is it's like a ball and socket, except you stretch it out so it can't spin anymore. So imagine maybe you have like a stick coming up like this and kind of like a football-shaped ellipse. And imagine that football-shaped ellipse goes into a similarly but inverted-shaped socket, kind of like that. So with a joint like this, you would be able to move it like this, and you would be able to bend it like this. I'm kind of trying to draw this in 3 dimensions here. You could bend it like this, but the one thing you could not do, because of this ellipsoidal shape, not spherical shape, you could not spin it, meaning you could not rotate it about an axis of rotation like this. That would not work. You could imagine trying to spin it like this, and the resistance of the ellipse shape would prevent you from being able to do that. That's not the case with a ball and socket, right? You can grab a ball and socket and you can spin it like that, no problem. Good example of where you see this is the wrist joint. That's probably the best example, because if you grab your wrist and try and spin it, Don't do that too hard because you're going to sprain your wrist. Because of the configuration of the bones, that's just not a motion that's permitted by the geometry of the articular surfaces. Lastly, and this is, I really only know one good example of this one, is a saddle joint. And it's very much like an ellipsoid joint in that it can move in two directions, but it cannot spin. But it's like two surfaces sort of paired with each other. So you could imagine, it gets its name from like a horse saddle. So imagine you had a horse saddle like this, kind of like on a block, say. And then let's say there was another one, but oriented perpendicular, maybe oriented like this. And this is going to be tricky because I'm going to, it's like we've grabbed the bottom one and flipped it around, and now it's up kind of like that. Now this configuration can rotate like this because that's like the saddle surfaces sliding like that relative to each other. And it can rotate, again, trying to draw in 3 dimensions here, like this. Again, they're sliding sort of relative like this, but they can't spin very much. Cannot spin. This one less important because really the only good example I know of is the thumb. The only difference between these two in terms of like practical terms is this saddle joint configuration is more stable. It's like a more stable ellipsoidal joint. The other thing I want to give you in this video is a really useful way of thinking about different joints. And I'm going to introduce a term that maybe you've heard, but I'm going to give it a formal definition. And that term is degrees of freedom. And the degrees of freedom of a joint or of a system as a whole tells you how many ways can this move? So thinking about the degrees of freedom of a joint, or even the degrees of freedom of a set of joints, can be a really, really useful way of thinking about how unrestricted it is in terms of its motion. So let's do that for these types of joints right here. Let's think about how many degrees of freedom do they have. As you might guess, a hinge joint or a pin joint, same thing. It has one, and I'm just going to use abbreviation DF, it has 1 degree of freedom, right? It can move on this coordinate. It can flex and extend, right? It can rotate this way, it can rotate that way. That's it. Now, a ball and socket joint has 3 degrees of freedom. If we were thinking about the hip joint, right? The hip joint what can it do? It can flex and extend. It can rotate internally and externally. And it can adduct and abduct. Right? It can move in 3 separate coordinates. So it has full unrestricted 3 degrees of freedom. In our little schematic here, we could think about that as rotating this way, rotating and trying to draw in 3 dimensions here like this, and spinning like that. 3 degrees of freedom. A pivot joint, how many degrees of freedom do you think this has? Well, it can just rotate like that. It has 1 degree of freedom. All right, that's all it can do. It can just spin. That's it. Spin left, spin right. Ellipsoidal and saddle joints. What's interesting about these, and you can probably guess by the way I drew them, each of these has 2 degrees of freedom. And that's because they can rotate this way, they can rotate this way, but they cannot spin. Right? Rotation here, fine. Rotation here, fine. You have unrestricted sliding between these two surfaces, but no spinning. So only 2 degrees of freedom. So the idea of degrees of freedom is an incredibly useful way to think about how restricted or not restricted is a set of joint motions. Now, the last thing I want to bring up is the idea that we can consider movement in 3 dimensions. 3D, we can consider that as having up to 3 additional degrees of freedom. Because this is, we talked about rotations, right? You can rotate 3 different ways. But by virtue of the ball and socket being, stuck inside, the ball is stuck inside the socket, it can't move at all in terms of like where the center of that goes. So it's stuck. So it can't move in 3 dimensions at all. But later we'll talk about things that have maybe even more than 3 degrees of freedom because they're free to move in space. But we'll talk about that in a later video. Hopefully this review of types of joints and their degrees of freedom is useful when we think about how can joints move in the body.